Hello, this is G. Ramesh Kalyan, Assistant Professor, Department of Computer Science and Engineering, SNS College of Technology. The course code and the course name is 23 CSP 201 Object Oriented Programming. This is Unit 1 Introduction to Object Oriented Programming, and the topic is Java Architecture. So, before getting into the Java architecture, we'll see what is in Java. So initially Java is a high-level programming language. It is used most widely. It uses the concepts of object-oriented programming language. This is also called as object-oriented programming concepts like encapsulation, abstraction, inheritance, and the polymorphism. So this Java was initially found by James Gosling at Sun Microsystems. Then later on it was acquired by the Oracle Systems. So Java is a platform independence. It has high security features and the performance in it. So as compared to the other programming language, Java is highly securable, and it is an open source. So initially it was not an open source. Then later on, after a few years, based on its usage and its working procedure, so Java was made open source with the GNU public license. So Java works on a principle like WORA, so which can be abbreviated as write once and run anywhere. So this means, as we saw previously, Java is an open source and platform. It has the platform independence, so that it can be installed in any systems irrespective of the operating systems. Either it could be an Windows operating system or else other one. Java can be used in any platform, so it is platform independent. So it has many updates in it, many versions of updates. So we can either use its either of its new versions, or else we can use the base version itself. So it gives the freedom of write once and run anywhere option. So next, coming to the Java architecture. So Java has different architecture layers. So some of the most widely architecture layers that has been engaged with it are: the first one is application layer, and the second one is Java API layer, and the third one is JVM layer, and the fourth one is hardware or OS layer. So starting from the application layer. So application layer has the user code. It acts as a user interface. So it fully contains the user codes. And second one is the Java API layer. So this contains the libraries like the collections or input output functions in it. And next one is the Java JVM layer. So this is called as the Java virtual machine layer. So this is used for the execution purpose, and it is also called as an execution engine. And next one is the hardware or OS layer. So this is an abstraction layer. So it is mainly depends on the hardware or the OS functionalities. So this indicates the famous Java platform components. The first one is Java virtual machine, as we saw previously, JVM. And next one is the Java development kit, that is JDK. And next one is the Java Runtime Environment, that is JRE. So these three components are called the Java platform components, and these components are used most widely. So we'll be seeing its purpose and usage in the next coming slides. So as we saw in the previous diagram, so Java virtual machine, JDK and JRE are the three main components or three core components of the Java architecture. So first one is Java virtual machine. So this Java virtual machine mainly enables all the Java applications to be platform independent. So as we saw previously in the introduction to Java, so it is in Java is an platform independent, so that it could be installed and worked on any platform, that is any OS as we wish. So Java virtual machine plays an important role in the process of platform independent. So next one is the Java development kit. So it is called as JDK. So this is mainly used for the Java developing applications, for developing the Java applications. So as we consider, so as a whole, as we consider, Java is divided into 2 to 3 steps. So initially the JVM, JDK and JRK. So JVM is mainly focuses on the Java application, and next one is JDK. It mainly focuses on the developing the Java applications, and the third one is JRE. So it is also called as a runtime environment. So it is used for running the Java applications. So JRE is a runtime environment used for running Java environment or Java applications. So this is an figure indicating the Java virtual machine. So Java virtual machine is further subdivided, or it has again it has some 4 components in it. The first one is class loader system. So it is delegation hierarchy. So it is mainly used for delegation hierarchy. Next time is runtime data area. So this data areas contains heap, stack, method area, and PC register. So these are the components these are the sub components that are available in the runtime data areas. And next one is the garbage collector. So this is mainly depends on the memory reclamation, that is the memory location process, and the memory leak prevention. So mainly a garbage collector, the main function of a garbage collection is the unused data or the unused bytes are being transferred to it. So that is known as the garbage collector. And finally the execution engine. So this is also called as an interpreter or a JRT compiler. So this is mainly used for running the process, or used for the execution process. So this Java development kit, so it has few components in it. So as we saw in the diagram in the last slide, so it has Java compiler, so that is Java C, then Java debugger, that is JDB, and Java archive, that is JAR. So these are the JAR is a file, it is a kind of extension, file extension. The next one is the Java doc. So this is mainly used for generating the API documentation from Java source code. So Java runtime environment. So this Java runtime environment has few components embedded with it. So first one is Java virtual machine. So as we saw previously, JVM. Then class libraries and all the supporting files. So these JRE is mainly used for the runtime environment, that is used for executing a file, and it has the following Java virtual machine files and JVM files and class libraries and all the supporting files into it, so that the runtime so that the runtime execution processes work smoothly. Thank you.